condition, we can model the chimney as a two-dimensional element, okay, with certain assumption. That we have to make here, the temperature inside the chimney is uniform from the top to the bottom, or from the bottom to the top, constant at 100 degrees Celsius. Okay, but by common sense, we know that that is not the case. Because usually the bottom part is hotter than the top part, right? Because the bottom part close to the fire, so of course it is hotter than the top part. But for the purpose of this example, let us assume that the temperature inside the chimney is 100 degrees Celsius from the top to the bottom. Okay, so since we can assume that, okay, the temperature distribution across the chimney should be uniform. Whether we try to find the temperature at the bottom, or at the middle, or at the top of the chimney, okay, the temperature distribution across the chimney should be the same. It should have the same temperature value, because inside the chimney it is 100 degrees Celsius from the top to the bottom. That's the assumption. And then from there we can model the chimney as two-dimensional element. Okay, try to imagine that maybe we cut through the middle section of the chimney. Okay, cut half the middle so we can see the temperature distribution inside it. In this case now, chimney, okay, has what we call the symmetrical value, symmetrical dimension. It has symmetrical dimension, where we have option here. We want to study the whole structure, the whole cross section with a rectangular shape, and the rectangular hole inside it. We can model the whole structure, or we can model half only. We can cut through the middle here. You can cut through the middle, model the right half or the left half, or we can model it as a quarter model. Maybe we can choose the top quarter here, the right top right here. Or we can cut further into 1/8 model, 1/8 1/8 model. Okay, the reason we can do this is because the shape is symmetry. Okay, if we find the temperature here, the temperature here at this part here will be similar to this side here. Similarly, temperature here at this part here similar to this side, and actually this part here only 1/8 model represent the whole temperature, okay, on across this chimney here. The benefit of using or reducing this model into 1/8 model is we can calculate this faster, because we only involved with let's say we only need to calculate 5 elements here. Temperature for 5 elements. Okay, if we calculate the whole structure, we need to to calculate temperature distribution, 5 element multiplied by 8, 40 elements. Okay, so it involves lots of time. We spend lots of time calculating this. It is not economical in terms of time, or maybe in terms of electrical cost. Okay, even if you use computer, we still need to spend more time doing the calculation by using the computer. So it will spend more money to calculate this. So in other words, we do this because we want to save time and when we want to save cost.
Doktor,
Yeah.
so kalau guna kaedah ni tak perlu kali 8 lah lepas dah kira semua ni?
Yeah. Tak perlu.
Oh, okay.
After we use this method, we reduce to 1/8. You will get temperature at node 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, on top of this, we know this is here is node 1, and we know temperature here at node 1, temperature at node 2 here. Okay, temperature at node 1. This node here will have same temperature here at this point here. It will have the same temperature at this point here and the point here. For node 2, it will represent temperature at this edge, this one, this edge, and this edge. Okay, when we calculate temperature here, 6 here, node 6, first node 3 here, it will represent temperature here, here, and here, sir. And then from this 1/8 model, actually you can calculate temperature for the whole structure. Let's say here, node number 5, here, actually you can actually, if you calculate node 5 here, temperature node 5 here, actually you calculate this point here, this point, and this point as well. Okay, actually we calculate the temperature of node. That's why we don't have to multiply by 8. Because the value of temperature here is not the multiplication. For the whole structure is not the multiplication of the structure. Okay, so what else? Okay, from here we can see that it involves rectangular and triangular element. We use a combination of both. Element 1, 2, 3, rectangular element. Okay, element 4, 5 are triangular elements. Okay, what else? Dimension given. Dimension given, the element with node numbers. Node numbers already given as well. And then temperature outside, the environment temperature, 30 degrees Celsius, H 20 watt per meter square degree Celsius. K given here 1.4 watt per meter degree Celsius as well. Okay, coordinate. Okay, coordinate given here. These are the coordinates for all the nodes. Okay, so now we can try calculate this. So I need to Excel. Cari Excel. Okay, Excel. Okay, Excel, class example. 2D transfer sini. Okay, copy the picture. Okay, next one is the coordinate. Okay, ready to go. So first, the table, FE table. In this case, we need two tables actually. One table for rectangular element and one for triangular element. Rectangular element and triangular element and rectangular element have different formula. Okay, what you can do actually, you can do two tables or you can combine in one table. Depends. It actually is up to you. You can do in one table, but it's going to be long, quite long table. Maybe you can do the first half here, rectangular table, and then the second half, triangular table. Okay, you can do that. But for me, I prefer to do two different table because we're going to work from top to the bottom. We're going to do rectangular element first. After rectangular element, we're going to do triangular element. So when it comes to the part to do the triangular element, if we put the value for triangular element here, we have to scroll back, top to bottom so many times, and it is hard to do. So I'm not prefer to do that. So I'm going to prepare two different table. First, FE table for rectangular element. So the element. Remember now we have node I, or maybe if you want to make it simpler, you can put I, J, M, N. So you know this is node, node I, node J, node M, and node N. Okay. Next, we want to calculate K due to convection. Due to conduction. Just go back to the formula. This is rectangular element. This is the formula. Okay, we need K. Kx and Ky have the same value in this case. So we only need to write K. K, W, L. We need K, W, L. Okay, and then formula KW over 6L. The next one is KL over 6W. KW over 6L. The next one is KL over 6W. Okay, the next one. K due to convection. What we need here is H. Okay, what is H? H is the length of the side. But in this case, I think H here, since our, let me show you the, okay, since the rectangular is a square rectangular, okay, where 1, 2, 2 to 4, 4 to 3, 3 to 1 are same dimension. 1 to 2, let's say the distance from node 1, node 2, you should node 1 to x 0.1, right? Distance from 1 to 2 is 0.1. Distance from 2 to 4 or 1 to 3, 1 to 3 y coordinate, 1 to 3 y coordinate 0.1, 0.2. 0.2 minus 0.1, we get 0.1. That means it is a square shape, rectangle. So we will have same value of what we call here in the formula here, we have same value of L here. Okay, Lij is equals to Ljm equals to Lmn equals to Lni. So L here has the same value, so we don't need to put Lij, Ljm, we just put L there. Okay, just put L. And actually L here is equals to W and L here as well. Capital L here, similar value with W. W is the width, L is the length. Same value. Okay, H divided by 6. I need to put H first. Okay, H L and then HL over 6. Okay, next. Okay, F, no heat source, no heat flux, but we have this HTFL over 2. HTFL over 2. Okay, we need TF here. So HTFL over 2. Okay, and that's it. So we have element, rectangular element 1, 2, 3. Okay, IJMN. So for element 1, 1, 2, 4, 3. 1, 2, 4, 3. Element 2, 3, 4, 7, 6. 3, 4, 7, 7 and 6. Element 3, 4, start here, right? 4, 5, 8, 7. 4, 5, 8, 7. Okay. Actually, the numbering is here is not optimized. What I want to say here is not optimized, because remember from the rule is the node number should be increasing manner, in increasing manner. For example here, okay, 1, 2 is okay, increasing. 2 to 4, okay, still increase. But here 4, 3, so decrease. 1, 2, 43. So this is not good numbering. The good way to number this. We will have a problem later on. Okay, I'll show you the problem. You will notice what's the problem later on. If we put the number with decreasing manner. Okay, so similarly here, 3, 4, okay, 4, 7, still okay, but 7, 6. Okay, here 4, 5, okay, 5, 8, okay, yeah, but 8, 7, okay, so decreasing. Okay, we just follow this, the example here. And then K value 1.4, 1.4, W here 0.1, things similar value 0.1. Okay, KW, K time W divide by 6 by L which is I 29. Okay, this one here KL divide by 6W, same value, same value because W and L have same value. Okay, save time, just copy paste. H 20. Okay, in this case, um, we can check here. H is used to find the K for conduction, K for convection, and F due to convection. So in this case, the surface that exposed to the surrounding is okay for element 2, 3, element 2 and 3 exposed to the surrounding. Element 1, no surface exposed to the surrounding because element 1 here situated here, this surface is not exposed. The bottom part actually is not exposed to surrounding, it is constrained at 100 degrees Celsius. So we don't need 20 there, we need 20 here for element 2 and element 3. Here we can put value but we don't have to calculate the value later on. 0.1. Okay, this is the length. Or you can ignore it. Because this part here is to calculate F due to convection from this part here for element 2 and element 3. If you prefer, you can just put that because it's not element 1 is not involved with this calculation here. So now H times L divided by 6 TF 30 degrees Celsius and HTFL H times TF times L divided by 2. Oops. tu 30 as well. Okay. Then that's the table. Okay, next we want to use the formula. Okay, this formula here. Just copy the formula. Okay, we're going to do this in local matrix, 4 by 4 matrix. K1, first K1 due to conduction plus K1 okay, no, sorry. For this element 1, no K1 due to convection. Okay, because not exposed to the surrounding, only K1 due to conduction. So in this case, we only have to calculate K1 due to conduction. Okay, put the label. Okay, TI, T1, T2, T4, T3. T1, T2, T4, T3. Kalau letak sini. Okay. Okay, this one is this part, the left part, and then the right part. Okay, equals to the total. Okay, this is the formula. Remember, the front part, and then second, and then this is the total. This part here equals to KW divided by 6L multiplied by 2. This one times 2. This one times 2 times minus 2. Okay. This one here times minus 1 minus that here times 1. Okay, minus 2 there. Okay, 2 here. 1 minus 1. This part here equals to this part. Minus 1, 1, 1 minus 1. So, equals to that 1, equals to this part, Control Shift Enter. This part here equals to this part here, so equals to that, Control Shift Enter. Then change the decimal places. Okay, that's fine. The next one equals to 2 times this one here. This one minus 1 minus 2. One, 2, minus 2, minus 1. Okay, this part equals to this part. Okay, this part equals to this part. Okay, then the total okay, that's it. The next one K2. Okay. Oh, what happened? Dia tertekan something ni. Oh, keluar gym dah. Kenapa? Ha? Hmm, okay, K2 dulu macam ni. K2 dia ke conduction tambah keluar. Ada sesiapa tahu macam mana nak betul ni? Ya, tak pasti saya tertekan apa tu.
Doktor.
Ya?
Doktor, dekat sebelah clock tu ada huruf I tu.
This clock ya? Ni ya?
Doktor tekan tu.
Oh, okey. Oh, patutlah. Okey, thank you.
Okay, doktor.
Dah seram lah, tiba jadi gym keluar dah. Gym noon lah. Okay, K2 due to convection. Due to convection. Okay, kalau nak lebih detail lagi, if you want to make it more precise, more detail. Okay, K2 due to convection at the top side. Okay, in this case, 1, 2, 3. 1, 2, 3 here. K2 okay, K2 T2, T4, T4, T7 and T6. T2, T4, T7 T6. Okay, add equals to okay. Now to save time, because for K2 you have to calculate K2 due to conduction as well. But since the dimension for element number 2 similar to element number 1, so it will have same value K due to conduction. What we can do is just equals to this one, just use this value. The difference is only the label here. This one is T1, T2, T4, T3. Here is T2, T4, T7 and T6. Okay, for this part here, we need to use the formula. Okay, in this case, K due to convection from the top side here, which is okay, which is the surface number 3. We go back to the question. For element 2, this is surface number 1, surface number 2, surface number 3. So 7, 6 here is for surface number 3, which is this formula. Okay, we copy this. Okay, we only need to fill here. Okay, because other parts equals to 0, that part equals to 2 multiplied by HL over 6. Find here HL over 6. Here equals to 1 times HL over 6. Okay, here 1 and here 2. And then add equals to this plus this. Control shift enter. Okay, that's for element number 2. For element number 3, same value with element number 2, only different label. Now with different label, what we can do is we can copy this. Okay, change this to K3. Okay, K3 there. And then label here for K3 4, 5, 8, 7. 4, 5, 8, 7. T, T4, T5, T8, T7. Okay. Okay, that's K1, K2, K3. Okay, next, we can calculate the load. Maybe we can do this side here. Okay, bring this here. Here. Or okay, just wait. Okay, I think we do this first. I do K first, because F we can do it in global when we want to add up the K in global later on. Next, we do this table FE table for triangular element. Okay, element. We need node 1, 2, 3. Okay, copy this formula here. Okay, 1, 2, 3 here is node, node 1, node 2, node 3. K, A, and then K over 4A. Okay, Y23, we do this in different table. Okay, the next one is K due to convection. Okay, from the question. Okay, from the question here, we have uh, element 4 and element 5. Element 4, no surface exposed to the surrounding, because element 4 located here, not exposed to the surrounding, but element 5 located here. Okay, this top part here exposed to the surrounding. In this case, we number it as element node 1, node 2, node 3. That means 5, 9, 8. 5 to 9 is surface 1. 9 to 8, surface number 2. 8 to 5, surface number 3. So surface number 2 exposed to the surrounding, right? 5 to 9, surface number 1. 9 to 8, surface number 2. So we go back to the formula, find surface number 2, which is here. This one here is surface number 2. L to 3 here. 1 to 2, surface number 1. Okay, H1. 2 to 3 here, surface number 2. So that means we have to use this formula, not this formula. So new, copy this formula, edit, copy. Okay. Paste there. Okay, so we need H. L and then HL over 6. Okay, the next one, F. Okay, due to convection. Surface number 2, formula for surface number 2. This formula here. Okay, we need H, TF, we need TF. L. Okay, so H, TF, L over 2. We have two elements, element 4 and element 5. Okay, triangular shape, 4, 5. Note number 2, 5, 4. 2, 5, 4. Element 5, 5, 9, 8. 5, 9, 8. Okay, 1.4. A. Okay, this is a triangular shape with right angle. So it's easy. 0.5 half times the base, 0.1 times the height, 0.1 as well. So we get A there. Equals to K divided by 4 divided by A. Okay, H 20 for element 5. No H for element 4, element 5 20. Okay, actually for element 4 you don't have to calculate this. Okay, L length, okay, 98. This length here exposed to the surrounding 0.1. Equals to H times L divided by 6. TF is 30, I think. Not mistaken. TF 30. And then H times TF times L divided by 2. Okay, save. Class example. Jadi okay, we put this aside first. Because we want to calculate this y23 there. Y23, y31. We can do this in another table. This table is for coordinate. What's the coordinate? This coordinate here. Take it here. That's the coordinate of the node. Okay, try to think the best way how to do it. We need to calculate y23, so that means we need to know what is the okay, I think we need to copy this. We need to copy this. Okay, node. One, two, three. Node one. Okay. 1, 2, 3. I think that's the way. Oh, no, not this one. Sorry. We just put this one. We put x or y 2, 3. Okay, something like this. Y 2, 3 equals to okay, y 3, 1. Okay, and then y 1, 2. Okay, y 2, 3, y 3, 1, and then y 1, 2. Okay, so y 2, 3, remember, node 2 and node 3. 2, 3, mean node 2 and node 3, which is actually y2 is y5. This is get a bit confused here. So 2, 3 here is the node numbering, the general numbering for the node for triangular element. Okay, remember this 2 and 3. This is node 2, this is node 3. Or maybe maybe I need to put node here. Node. Okay, y node 2, y node 3. That means y node 2 minus y node 3. Y node 2 minus y node 3. Node 2 for element 4 is 5. Node 3 for element 4 is 4. That means y4 minus y5 actually. Okay, y coordinate of node 5. Y coordinate node 5, 0.2 minus y coordinate node 4, 0.2 as well. 0.2 minus 0.2 equals to 0. Okay, we do this again. Y32, so y node 3, which is 4, minus y node, right? 3, 1. Sorry, this is 3, 1. Sorry, y23, y31. Okay, y node 3, which is 4, minus y node 1, which is 2. So y4 minus y2, y4 0.2 minus y2 0.1, 0.2 minus 0.1, you get 0.1 here. Okay, next one, y12. y1 minus y2, which is node 1 minus node 2, which is 2 minus 4. y2 0.1 minus 4 0.2, 0.1 minus 0.2 minus 0.1. Okay, boleh nampak eh? You follow this? Okay, because this is I understand it's a bit confusing.
Doktor boleh ulas semula tu.
Okay, I try with x. I try with x. X is same thing. Okay, next x. So to make it tidier, so usually x and y is opposite. If we have y23 here, we will have x32. See, we have x32. x32. Here we have y31. We should have x13 here. x13. Now we can check from here, we have x13. We have y12, we should have x21 here. We have x21. Only 3 numbers. Okay, only 3. We have 3 set here and 3 set here. Okay, next. Okay, now x coordinate. Previously y coordinates, now x coordinate. x32. That means x3 minus x2. Not this 3 here, not x3 minus 2 here, but we have to look at here x3, which is node 3 here is node 8. Okay, node 3 for element, this is element 4, right? Okay, element 4. So first thing I need to highlight, okay, first thing here, this is element 4. Sorry, element 4. Okay, x32 that means x3 minus x2. x32, x3 minus x3, x2. So x3, node 3, which is node 4. Node 3 here, see, node 3 refer to node 3 for element 4, which is node 4. Coordinate x for node 4, 0.1. Okay, that means 0.1. You can write 0.1. So minus x2, okay, minus xj 2, node 2, 5. So refer to x5, 0.2. So 0.1 minus 0.2, we get minus 0.1. x31, x3 minus x1 minus x3, x13, x13, sorry, not 31, x13, x1 minus x3, x1 for node 1, which is 2, minus 3, 4. That means coordinate 2 minus x coordinate 2 minus x coordinate 4, 2, 0.1, 4, 0.1, you get 0 there. x21, 2, 9, sorry, 5, 2, 5, minus 1, 2. 5 minus 2, here is 5, 0.2, 2, 0.1, we get 0.1. Okay, we have tips here. We should have 3 numbers here. In this case, we have 0, 0.1, and minus 0.1. Okay, if you have these 3 number here, you should have these 3 number this side as well, but with different order. This is the way you can check whether you calculate this right or wrong. That means you should have 1, you should have 0, we have 0 here. You have 0.1, we have 0.1 here. You have minus 0.1, we have minus 0.1 here. Okay. And these three numbers should be here as well, but just with a different order. Okay, maybe certain problem you calculate, you get 0, 0.2, minus 0.2. So you should have 0 here, you should have minus 0.2 here, you should have 0.2 here. Okay, there will always be one number equals to 0, one number is positive, and another one is negative. Okay, same thing for element 5. This is for element 4, but if you refer to this, you see element 4 here, the position, the orientation for element 4 and 5, okay, similar. Okay, if we do the what we call the operation, okay, minus of operation for element 5, we should get same value for element 4. Okay, if we minus, okay, 4y5 minus y4, we should get same value of y9 minus y8. Or if we do the minus of x2 minus x5, it should be the same value of x5 minus x9, right? Because same dimension, same orientation. So in that case, element 4 equals to element 5. The value for element 5 equals to for element 4. We can see here, this is for element 4, okay, and 5 as well. Because of the dimension, similar dimension, similar orientation. Okay, from there, we can calculate this. Okay, from there we can calculate this. It's already 11:51. I think we can stop here. We continue next week. Okay, maybe up to here. I open for question. I hope you understand this. You can follow this, the step. This is the most important step because it is a bit confusing with this number. So y23, x32. Okay, ada soalan? Kalau tak ada, kita scan scan attendance.